Hey guys, welcome back to our discussion on log functions. Where we ended last time, we were talking about vertical asymptotes. And so I want to talk more about those before we jump into the graphs. And so what we have right here, if you look closely, R2 is our definition of a vertical asymptote, right? A vertical line where the function is undefined. We'll talk more about that. The graph will never cross this. And the definition that we talked about with vertical asymptotes was that it sent our outputs quickly off to positive or negative infinity, right? So we saw the behavior of graphs doing something like this around those vertical asymptotes, which we represented with a dashed line. I wanted to revisit these examples because we do have an example of two graphs where there is a value that is not in the domain. So for example, maybe this is like -3, and then this whole, maybe there's a value not equal to maybe +2. So we still have this like undefined behavior, but when we're looking at graphs in particular, this is definitely going to be one key indication where our graphs go up or down or both. We can have a combination of different types of behavior. As long as one side is doing at least one of those things, that's what we got, right? And so what we talked about last time were these 4 examples of graphs with vertical asymptotes, and we did mention that this one in fact did have a vertical asymptote at x equal to 1 right here. We kind of see the behavior that we talked about where one end's going up to positive infinity, one end's going down to negative infinity. One thing we didn't talk about was the domain and range of this function, but before we do that, I do want to mention one thing, and that is the existence of a horizontal asymptote. There is, in fact, a horizontal asymptote here, right? Remember, that describes our end behavior when it gets very horizontal like we see right here. And the equation of a horizontal asymptote is y equal to some number, for example, 0 here. For our domain and range, remember, our domain is the set of all inputs, and our range is the set of all outputs or possible y values. So for this graph, our domain, right, remember we always list our numbers from smallest to biggest, starts at negative infinity over here, stops right here at x equal to 1, picks back up, and then takes off to positive infinity. So we have the domain negative infinity, what was it, +1, union 1 to positive infinity. For our range, very similar behavior, except now we're working with this axis, right? We start at negative infinity. Right here, we're going to make sure we don't include that horizontal asymptote, and the graph picks back up again at 0 all the way up to positive infinity. So our range goes from negative infinity to 0, union 0 to infinity, right? All real numbers except 0, all real numbers except 1 for the domain. Let's do another one. Here is an example of a log graph, something we are going to develop. Does it have a vertical asymptote? As you can see, we have what we talked about. We talked about it kind of like a wall. So we got this wall along this dashed line at x equal to 0, right? And since our graph is taking off to negative infinity, the answer is yes. We do in fact have a vertical asymptote at x equal to 0 because the graph goes to negative infinity on the right side of that value. Perfect. All right, let's talk about domain and range, set of inputs, set of outputs. Remember, domain, set of inputs. But if we notice, right, we don't have any part of our graph over here. It kind of starts up right here and moves in this direction. But remember, keep in mind, this vertical asymptote right here at x equal to 0 should not be included in the domain because that was the definition. So our domain is going from 0 to positive infinity, not including 0, right? We got no negative values. For our range, right, our range is the set of outputs along this axis. It looks like we have a graph that starts here at negative infinity, goes all the way up to positive infinity. This is going to keep growing even though it's got slow growth. It will in fact keep growing. There's no horizontal asymptote here, so our range in fact is all real numbers. So the interval from negative infinity to positive infinity. Let's take a look at this one. We got an example of a rational function. Look at both of those ends going up, going up. Right here, we can kind of imagine a little wall in between those two tails at x equal to 0. That's our vertical asymptote. If you notice too, we also have a horizontal asymptote right here along y equal to 0. I like to do this, have those labeled to help us with our domain and range. And so, yes, we have a vertical asymptote at x equal to 0 because on both sides the graph goes up to positive infinity. The graph goes up to positive infinity, which was the definition that we talked about for domain and range. Let's take a look at that. For our domain, right, we have negative values over here all the way up. It kind of stops at 0, picks back up again, takes off to positive infinity. So that's the interval from negative infinity to 0, union 0 to infinity. For our range, right, we don't have anything down here, and the negative value kind of start right above this horizontal asymptote and go up, 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 right? So that's the interval from 0 to infinity. For this last one, does the graph have a vertical asymptote? We do have a hole in the graph, so we do have a value that's not in the domain, -1. But because our graph doesn't shoot up to positive infinity or negative infinity, or both, or just one of them, right? In fact, there would be there is no vertical asymptote for this particular graph because our outputs don't go to plus or minus infinity at some specific value for x. I mean, sure, we've got this n taking off to positive infinity, but x is going to positive infinity also. And what we really want is x to be some specific number, like 7 or -2 or 0, like we've seen a couple of times. It does need to be a particular one. And so for our domain, we will have to take into consideration that hole that we talked about, right? Where there's a hole kind of right here at -1, but everywhere else is fine. And so we will have the interval from negative infinity to -1, -1 to positive infinity. So all real numbers except for -1. For our range, notice that hole again right here at -2, right? So I'm going to have all the values from negative infinity. I'm not going to include -2, but then if we take a look, we have points all along our graph all the way up to positive infinity. And so for my range, I have all real numbers, so negative infinity to -2, union -2 to infinity. All real numbers except for -2.